Alright, so I've got an Adcom GFA-5300. This thing came all the way from New York State. Just basically wants a checkout. I did power this thing up, and it does actually work, and it sounds pretty doggone good. But unfortunately, I was not able to connect the right input to it. I just had to use a jumper lead back here. And let's go ahead and flip this thing around, and I will show you why. So there is the left input. It looks perfectly fine. But when we go over to the right input, you'll see that the pin of the RCA jack is actually broken off inside the connector. And I don't see an easy way to extract that thing out of there. It's not hollow. I can't just push a pin from the backside out. But the good news is I do have these in stock, so it will be an easy replacement. Yeah, see, it's completely, it might look like light coming through there, but if I shut the camera light off, it's totally solid on the inside. There's no pass through. So basically, this customer just sent this in here, wants me to check the capacitors and whatnot. Right off the bat, look at the date code, 9643. That's the 43rd week of 1996. These are definitely getting up there in age. Are they all the same? 9646 on that one, so 43 and 43. We got one that's a 46. Obviously a different batch. They probably just had a box of 1,000 of them and they put them together. But I thought we'd go ahead and pull the amplifier boards out of this unit. Check all the capacitors. There's a couple of 220 microfarad, 100 volt caps on here. Some small miscellaneous caps. We'll go ahead and unsolder the driver and output FETs. These are MOSFET transistors. They're not bipolar. Test them on the MK168 and just check and see what they actually have to say. So I'm going to start by checking the 4 main filter caps. This unit uses 2 capacitors on each channel, one for positive and one for negative per channel. So they're basically isolated channel to channel. They currently are Nichicon 85 degrees Celsius 10,000 microfarad 63 volt caps. And so on a capacitor like that, I want to see a maximum of 0.01 ohms ESR. I'd like to see 0.0. But if I see 0.01, I'm going to deem that acceptable. If I see like 0.05 or 1 ohm, it needs to get replaced. Now, just based on the assembly date of this unit, 1996, it's 26 years old as of this time. And according to the date on the back of the unit, it's 1997. So that makes this unit 25 years old. The capacitors were obviously produced before the unit was built, which makes them 26 years old. So let's go ahead and get the blue ESR meter out and we'll check all 4 of these capacitors. So first I'm going to do a lead integrity check. And I see 0.0, that's perfect. Ooh, I do see 0.02. Let me make sure I'm on there good. Oh no, there we go, 0, 0 to 0, 1. I'm happy with that. Next one, lead check again, 0, 0. And I do see 0, 1. There it goes, 0, 0. Happy with that. Lead check, 0, 0. And 0, 0 on the capacitor. Perfect. And the last one, I see 0, 0. So I'm happy with these 4 filter caps. So next, let's move on to one of the 2 power amplifier boards. Okay, this is the left channel power amplifier board. It has 3 47 microfarad 63 volt capacitors on it. And first one, I'm going to do a lead check once again, 0, 0. And I see 0.27. That's excellent. Second one, 0, 0. And I see 0.25. Perfect. And the third one lives over here in the corner. Lead check, 0, 0. And 0.32. If it was half ohm or more, I'd be suspicious, but just because they're in the 0.2 to 0.3 ohm range, I'm perfectly happy with that. These are the 220 microfarad at 100 volt caps, 0.03, that's excellent. And 0.03, 0.04, once again, lead check, we're at 0. So, at least on this amplifier board, all the capacitors look absolutely perfect. We can go ahead and check the emitter resistors with this ESR meter. It will measure resistance as well. And they should be, I think, 0.3 or 0.33 ohms. That one's perfect, 0.3 ohms. 0.3. 0.3. And 0.3 ohms. Absolutely perfect. So let's go ahead and unsolder the 4 MOSFET output transistors as well as the 2 MOSFET driver transistors. And we'll try to do it all in circuit. I really don't want to have to take them out. They are ESD static sensitive. So let's go ahead and get those things unsoldered and check them with the MK168 and just see if any of them look suspicious at all. So I went ahead and pulled the amplifier board off this unit. I do have it resting on my anti-static mat right now. And I've got to say one thing, they are not consistent. Look at the date codes on these 2 FETs. This is one pair, 9635 and 9633. They're made 2 weeks apart. Maybe they're a match set, I'm not sure. Let's take a look at the drivers. So one is an IRF 9610 and one is an IRF 610. And the date codes 9623 and 9627, 4 weeks apart. And then to the other 2 output FETs, they are both IRFP 9240s, 9615 and 9639. Those are almost 30 weeks apart. Well, let's go ahead and get the MK168 and we'll test each one and see how close they actually are. Okay, here we go. Testing the first output FET. So I've got 572 millivolts, 2.91 nanofarads, and a voltage of 3.6. On to the second one. 567, a little bit different, 2.97 and 3.6 volts. Remember, that's an N channel. These should be P channel over here. P channel, 1.18 volts, 2.02 nanofarads and 3.4 volts, 1.17 volts, 2.07 nanofarads and 3.4 volts. They're close. At least they have emitter resistors, so that'll make up for any gain discrepancies when they're driven lightly. Okay, now on to the driver FETs. 1.56, 337 picofarads, and 3.7 volts. The other driver FET, 631 millivolts, 331 picofarads, and 3.9 volts. I'm going to say those are close enough for government work. Not off by more than a couple of hundreds of volts, FET to FET. So I'm going to deem this channel good. Everything's working perfectly. We don't have wildly mismatched transistors in this unit. So next we'll go ahead and pop this one back in and I'll pull the right channel out of the unit and we'll test all of those FETs as well. Well, it's definitely in better shape now than it was when it got here. Definitely cleaned all the flux off the board. I did go ahead and resolder all of the emitter resistors as well as these 5-watt resistors, these 4 of those right there. And the offset and bias trim pots that live right in that area there. So definitely cleaner than when it arrived. Always leave your surroundings better than when you got there. Okay, on to the right channel. First, the 47 microfarad caps. 0.25, let's verify lead integrity once again. 0.0, perfect. 0, 0. 0.27, excellent. 0, 0. And 0.23, I'm perfectly happy with those. On to the 220 microfarad caps. And wow, that one reads 0, 0. Excellent. And 0, 0 on that one too. That is quite interesting. Let's check the emitter resistors real quick. 0.26. 0.26. I'm going to double check my leads. Okay, zeroed out once again. 0.27, 0.28. 0.27, 0.28. 0.27, 0.28. And 0.27, 0.28. Wow, I can't believe these things are 0. All right, 0102 and 0102. Wow, those are an excellent help. And on to a close-up view on the date codes on the right channel. The IRFP9240s, 9639 and 9615. The IRF610 and IRF9610, 9627 and 610 possibly. I see a 4499. I'm not sure about that. Maybe it's 9610 on this one. The other two output transistors, they're both matched 9639. Well, somebody was in a hurry to put this thing together. They couldn't even line up the insulator pads. Well, it is assembled in China, so what do you expect? Okay, let's get the MK168 and check all of these FETs. Okay, first FET, 1.15 volts, 2.09 nanofarads, and a VT of 3.5. Okay, on to the second one, 1.12 volts, 2.01 nanofarads, and 3.4 volts. On to the third one, 0.569 volts with 2.97 nanofarads and 3.2 volts. And the last output transistor, 572 millivolts with 3.04 nanofarads and a VT of 3.2 volts. Now on to the drivers. 631 millivolts, 329 picofarads, and a VT of 4.0. And last, 1.38 volts, 320 picofarads, and 3.1 volts. And just like the other channel, this channel is leaving in better condition than when it got here. Did go ahead and resolder, once again, the emitter resistors, both sets of 5-watt resistors, the bias and the offset pots right there, as well as the thermal tracking FET in the center right there. So yeah, definitely leaving in better shape than when it arrived. And I did go ahead and do the bias tracking FET and the other one as well. So contact the customer, see what he wants to do. Does he just want to throw a bunch of caps into this thing or use it as is? It will need that input jack replaced. That's the only thing I haven't done yet. Okay, I do have it back together, and I'm going to go ahead and adjust the DC offset because I see it has about 18 millivolts DC offset. So this pot does adjust the DC offset. I'm going to dial it down a little bit, let it stabilize. 3. And so we're kind of hovering around 0.1 to 0.7 millivolts, which is great. Hit it just a bit farther. Let it stabilize for a second. Nope, a little bit too far. I mean, 1 millivolt of DC offset is absolutely perfect. Let's just go ahead and put this on average. There's average. Yeah, 0.7 millivolts DC offset. I'm not worried about that in the least. Let's go ahead and do the other channel now. It's actually coming closer to 0. 0.1 millivolts DC offset, 0. Yeah, not worried about this in the least. And on this channel, we do have 8 millivolts of DC offset right now. And that's obviously going the wrong direction. Anytime you do an adjustment, let it stabilize for 5 or 10 seconds. So we're hovering around the 1.9 to 2 volt millivolt range. I'm going to call that good. Okay, so let's go ahead and do the bias adjustment, and I'll pop up a page from the service manual right here. You can go ahead and pause it and read it if necessary. But I'm going to go ahead and adjust R143. I do have my meter on the bias test points right here. Now, interestingly enough, the service manual tells me to use this emitter resistor right here, but they've conveniently supplied test points right here that I'm going to use. I went ahead and checked the voltage on this emitter resistor. It's exactly the same as this one, so I don't think it's really necessary to use R138. I'm going to use R140, I believe. Yes, R140. So it says make sure this thing's up and running and stabilized with no audio source. Well, it doesn't say that, but I know, for at least 5 minutes. So I've had it up and running for about 10 minutes right now. And I'm going to go ahead and adjust this pot right here until I see 20 millivolts on the display. And I don't think it's going to be, yeah, I can go down virtually to 0. I have the leads connected backwards, which is why it's negative, so don't even worry about that. It says 20 millivolts plus or minus 2 millivolts. So there's 20.3. We'll let it set for just a minute, and the bias may actually come up very, very slightly. I would honestly rather have a slightly low bias than a slightly high bias. I don't want thermal runaway. If everything's working correctly, it won't. Well, I'm going to call that pretty good at 19 millivolts on that channel. Let's move over to the left channel. This is currently the right channel. But before I move to the left channel, let's go ahead and double check our DC offset adjustment. And I'm perfectly happy with that. So we're just going to let that one ride. I already adjusted this in a previous shot, so I'm good with that. Very close to 0. I believe it says plus or minus 10 millivolts. So let's go ahead and move over to the left channel now. We'll check the bias on it, and once again the DC offset. So there's the DC offset running about 1 millivolt, 1 to 2, perfectly fine with that. Let's go ahead and connect the test leads up to the bias test point, which lives right there. And we're running 17.7. I'm just going to go ahead and adjust it to about 19 to 20 if I can. Whoop, too far. Way too far. Very touchy. Wow. Why you got to be like that? Okay, 19.2. Perfectly fine with that. All right. I'm going to go ahead and wrap up this video. All right, MP3 player is connected. Let's go ahead and hit the go button here. And I do hear audio. And it's working great. Nope, can't play that song. Well, I think that's going to be it. I did replace the right channel input jack back here because, as we discussed earlier, it does have the pin broken off in the center of it, so you cannot connect an audio source into it. All the capacitors check perfect on this unit, even the main filter caps. So I don't think there's anything else that needs to be done to this unit. It's working absolutely perfectly. I know you hate that I say that, but it is working absolutely perfectly for a 25-year-old amplifier. And I believe this thing is rated, let's turn that down a little bit. I believe this thing is rated at 80 watts per channel at virtually no distortion, like probably 0.01 or 0.05%. Very nice, well laid out, designed in USA, unfortunately built in China. Anyhow, go and leave me a question, a comment, a concern down below, good or bad. I try to respond to the comments when I have time. While you're down there, hit that subscribe button and like this video. It really helps my channel grow, and it helps recommend this video to other users like yourself. You can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me, NorCal715videos@gmail.com. That is the best way to contact me. Please be patient. I have a full-time job and I do these repairs in my spare time. Incidentally, if you try to contact me on any of the social media platforms, it might be weeks or even months before I respond. I rarely check those messages. Please, if you want to contact me, use the Gmail address only. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone, thank you for making it to the end of this video. I really do appreciate it. Everyone, have a great day. Once again, thank you so much for watching. Stand by for bloopers. Oh man, why didn't you guys tell me? I missed that capacitor when I was doing the capacitor checkout. This is a 4.7 microfarad 50 volt capacitor. And I had the unit all back together. I even had it packed up in the box. Had to unpack it, tear it all apart. I don't want to miss anything for this customer. So let's flip this board over, do an ESR check on this one lone capacitor. Well, two of them, there's one on each board. And to make matters worse, it has a 0.1 microfarad. I think that might be a ceramic cap across it. I'm just going to go ahead and heat up one end of it and pick one end up so that way I can get an accurate reading. Uh-oh. Now I need to find another 0.1 microfarad cap. Doggone it. Okay, and the winner is, I'd like to see probably 10 ohms or less. And I see 4.1, 4.2 ohms on that capacitor, so I'm pretty happy with that. Now, as far as the capacitor that I destroyed, I see 14 ohms, 18 ohms on that one. And that's a 0.1, so the capacitor that I have to replace it is a 0.1 at 400 volts. That's all I have in stock. And it reads 16 ohms, so it does read better than the original one, so I think that's going to be just fine. Yeah, I'm going to go ahead and leave that one in. These are Panasonic capacitors right here, 4.7 at 50 volts. And they read 6.8 ohms, so the capacitor that's in the circuit actually does read better than the replacements that I have at 4.4 ohms. So we'll go ahead and put this 0.1 across that cap and get this side put back together. Okay, new capacitor installed here. And I see 2.7, 2.8 ohms total with both capacitors. I'm perfectly happy with that. I'm sure the other channel is going to be almost identical, but I'm going to find out just to make sure. I'll probably just go ahead and strip off that little cap and put a new one on there just to be safe. Okay, on to the other side, untouched. And I see 3.6 ohms on that one. So I'm going to go ahead and take that little 0.1 capacitor off of there, and we'll check the ESR of the 47. And like I said, I'm just going to go ahead and throw a new 0.1 on there because I know that I'm going to end up destroying this one too. Trying to just get the whole thing to heat up. Well, I got it out. I don't think I destroyed it. But unfortunately, the capacitor fell out of the board. So now that the capacitor is warm, I'm not going to get an accurate reading on it. Yeah, see, I see 2.3, 2.4 now. So I'm going to have to let it cool off to room temperature before I can actually check this capacitor again. Alright, so it has been sitting for about 10 minutes, so it should be up to ambient temperature by now. And I have not soldered it yet. It's just in here with the leads folded over a little bit. And I see 3.5, 3.6, 3.7 ohms. I am perfectly happy with that. And just for the heck of it, we'll check the 0.1 that came out of the unit. And I see 18 ohms on that one. So yeah, I'm just going to go ahead and put a new one in there. Call it a day at this point. I just didn't want to miss anything for this customer that has sent this unit 3,000 miles. Okay, so there's the new one. And I see 17 ohms on that one. Virtually exactly the same as the original. So I think we're going to be just fine. All right, lead check, 0.0. And I'm seeing 3.6 ohms, almost identical to the other channel. So good with that. throw this thing back together. I'm going to power it up one time just to make sure I didn't screw anything up, rebox it, get it ready for shipment. So if this seems out of order, it was out of order. So let's give it a final test now, as I did previously. Okay, so after I've done the testing of the two 4.7 microfarad capacitors, I want to verify that I have good offset and bias adjustments because that capacitor is in the bias circuitry. So they tell me to make sure I have 115 volts AC, and I'm pretty close, 115.6. We'll put this back on millivolts, and I'm going to test offset. And I've got 3.4, 3.3 on one channel, 6 millivolts on the other channel. It specifies plus or minus 10 millivolts. And now for the bias, I want to see 20 millivolts, plus or minus, I think it was 2 millivolts. So I've got 20.7. And 20.0. Okay, I'm very happy with that. Let's put some audio back into this thing. And it's working perfectly as it was previously. Very happy with that. So this little addendum, testing the two capacitors that I missed, that was my mistake. Like I said, I completely unpacked this unit, went ahead, pulled it apart again, pulled both boards out of it, and retested those capacitors. Anyhow, once again, stand by for bloopers. But unfortunately, I was not able to connect the right speaker. It has three 47 microfarad 6. These are the 100. See if these leads can get in the way of the display. Oh, not too bad. We're on to the 100 micro. Second one, 1.12 volts, 1.64 nanofarads. Oh, whoops, my bad. On to the last output transistor. Now, interestingly enough, the service manual tells me to use this bias resistor. So I'm going to remove the test leads here. And I'm going to reconnect them back to the speaker terminals on the back of the unit here. And I'll have to use other test leads. That's not going to do it. I want a flat screwdriver. There we go. It